like it. All right, I think 1 minute in. Let's try go live. I'll just give the users 1 more minute. The delay is actually quite insane. Currently, it's still speaking about traffic on YouTube. Let's see. Okay, it's 11:30. We can start now. So, hi everyone, and welcome to QGIS Open Day. I'm Luna, currently working at Cartosa. Amy will not be able to join us today, but she sends her warmest regards. Today, we have the pleasure of having Ujaval join us, and we'll be presenting on solving spatial analysis problems using QGIS. Over the years, he's been creating and sharing fun spatial analysis problems using hashtag Spatial Analysis Challenge on Twitter and LinkedIn. These challenges are inspired by real-world issues. Today, he'll be showing us some of the previous challenges, ranging from expressions, geometry generators, processing algorithm, PyQGIS, my favorite, and much, much more. So we'll be having a very interesting presentation ahead of us. Quite excited. So without further ado, Ujval, please present to the users. The platform is yours.
Great. Thanks, Runa. Thanks for the introduction and hosting this session. It's really excited to be here. This is, I think, my fourth time presenting at QGIS Open Day. It's always fun. Let me just share my screen and open the presentation. I'll be sharing a lot of different data sets and procedures and a lot of code, etc. All of the stuff that I'm sharing is available in this presentation. So if you just want to access this and follow along, you can go to this bit.ly link here. And Luna, if you can share that link in the chat so that people can access that. So everything you need should be available here and you can follow along. I run a small company called Spatial Thoughts. We are a learning company, so I create a lot of learning materials on all topics on open source geospatial technologies such as QGIS, Python, Earth Engine, GDAL, and again, they are widely used. We also make all our course materials, YouTube videos, blog, etc. available under a very open license. So if you're an educator, trainer, you can take this, translate it, adapt it, and teach it. So please feel free to take this material and spread the open source lab. We also run online instructor-led classes on all the topics. We have a lot of QGIS courses that you can check out. We're also a certified training provider, and we try to support QGIS project as much as we can, and we are a sustaining member for the project. About the topic at hand today, this is something that, as I teach a lot of QGIS courses and we have a lot of participants, sometimes we come across this interesting spatial analysis problems that are not very straightforward to solve. But again, they're widely applicable to real world problems. And when I encounter such problems, I try to package it up and post it so that people can try to solve it using whatever software they are comfortable with. The idea for this is that we might know one or two ways of doing this, but people can have really creative ways to approaching these problems, and we can all learn from each other. Whenever I post this, I always end up learning so much about different platforms, different approaches to the same problem. So I want to present some of those challenges today, and I've selected a subset of those. These are all the different challenges that I posted over the years. If you want to see all of them, the link at the bottom will take you to a playlist with video explanations and data sets and all the different solutions that people have presented. But today I'm going to present a subset of 3 challenges. We don't have time for everything, but I selected these 3 because they are very diverse in the kind of technologies that uses within QGIS. So you will get a good overview of what is possible in QGIS, and you'll also see how different people have approached the same problem and solved it in creative ways. So we'll start it. At the end, I have a bonus challenge for you. This comes from Herman, and he's also here, Herman. And it'll be nice to see how people approach this problem and apply their QGIS skills to solve that. The first one, it's a challenge that came from one of our participants who works in a utility domain. They wanted a way to visualize and connect each building to the nearest place on the road. So this is a visual representation of what you want. You have a set of building polygons. These are from OpenStreetMap, but you have building polygons and you want to connect the road-facing edge of the building to the nearest place on the road. And the idea would be if you want to have a distribution line, a utility line, and you want to know how would you connect that particular building, what would be the shortest path for that. So this kind of seems like an interesting problem. It is at least the software suite that we typically work with, QGIS, GeoPandas, etc., do not. All right, I think we had a bit of interruption. Let's get started. So we want to now solve this, and let's see how we can solve this in QGIS. There are multiple approaches. The first approach that I stumbled upon was to use the built-in tools in the QGIS processing toolbox, and we can chain them together to build a workflow that can solve this problem. The main challenge here is how to find the road-facing edge of a building. And the way we do this, we'll break down the building into lines, and we'll find each constituent line segment. We'll find the centroid of that line and then connect that to the nearest point on the. We'll find the centroid of that line and then connect that to the nearest point on the line geometry. And this is the kind of workflow I decided it works. Let's just take a look at how to do this in QGIS. So I'm going to switch back to QGIS and we'll see how to solve this problem. So here we are in QGIS. We have the roads layer and the buildings layer. So first step is to find the centroid of each edge of each segment. So let's see how we can do that. So we have building polygons. There is this nice tool in the toolbox called polygons to lines. This turns your polygons into line features. So let's take our buildings and turn this into lines. So you can see now we have this line layer, and this still one line feature for all of the edges. So we have a multi-line feature that is constituted of all these 4 edges. We actually want to extract each face separately. So we can use this really handy tool called explode lines. This will give you one feature for each segment of a multi-line segment. So let's run this. And now, if you take a look, you can see now I have individual line segment. We can now run the centroids tool, and the centroid will give you the center point of the road facing edge or each edge of the building. So here, in just a few tools, we could extract the centroid of each of the building's faces, and now we can go and connect this to each to the nearest point on the road. There's this really nice tool called shortest line between features. Super helpful. This particular tool takes either point line polygon feature, and for each feature in a layer, it can find and connect a line to the nearest feature from another layer. Just yesterday, one of our class participants asked they wanted to do something similar, and again, a tool like this is really handy. So let's take our centroids there, and then we can connect it to the nearest points from the road layer. And it can connect to the centroid of the features or just the nearest point. So whatever point is nearest, there need not be a vertex there. Go ahead and run this. And now we have connected the centroid of each face to the nearest line, nearest point on the nearest road. This is almost the solution that we want, but you can see there are 4 lines from each building, or however many faces are there. If I open the attribute table of this, you will see that for each feature, if there are 4 edges, I have 4 different lines. Each of those lines also have an attribute of the distance from that centroid to the nearest line. What we want in our analysis is to find the shortest of these. So if we pick the line with the shortest distance, that would be the line that connects the nearest face of the building to the nearest point on the road. We can do it multiple ways. We can use an expression. We can use a SQL query to do this. But I want to show you one more tool, which I have used and repurposed many times for doing this kind of analysis. And that tool is called Add Auto Incremental Field. This tool allows you to add a new column to your data layer, which is a sequential ID. This is typically used when you bring in data, like if you bring in CAD data to QGIS, doesn't have a unique ID, you can use this to create a unique ID. But we can repurpose this for us to find the ID of the shortest feature in a particular layer. So I'm going to rename the field that we want to generate called rank. We'll start the values at 1, and we'll group them by FID. So we have the same FID for all the 4 features of a building, and we have those lines. So we'll say group them. For each group, compute the rank from 1 to 4, but we can specify a sort expression. So here we can say rank them by the distance. So we'll have the values 1, 2, 3, 4, but 1 will go to the shortest value of the distance. So let's run this. And now if I look at the attribute table of the resulting layer, you can see I have rank field. If I sort it back by FID, you can see I have 4 features. Now I have rank 1, 2, 3, 4. The rank 1 is assigned to the one with the shortest distance. And now we can use this field to extract the features that we want. So I'm going to use the extract by attribute tool to extract and say, give me all the features with rank 1. So that's the shortest line from the building. And this is our result that we wanted. So we have now the buildings, roads, and a line connecting the road facing edge to the nearest point on the road. And this is done purely using all the built-in processing tools. You can see the analysis was fast, fluid, and you could just chain multiple tools together. And the advantage of doing this is now we can put everything together in a model. So instead of kind of doing all the steps ourselves, if we had to do this for a different region or want to repeat the analysis, we don't have to kind of do all the steps manually. We can say, I have my input data, we can build a model. So I built a model in the QGIS modeler. This allows you to drag and drop different tools and build a workflow. So again, this takes 2 inputs, a building layer, a roads layer, and goes through the same workflow which I showed you, and it'll generate a result for the output. So let's run this tool. This looks like this. We specify the inputs that we want, and now we run this tool, and we get our result that we want. Right? So this is also useful when you want to do this multiple times. You want to share this with a colleague and say, this is the workflow I built. You can run this. You can use the modeler to do this. So this is the one approach that I did, and I was pretty happy with it. And I posted it out to the community to try and solve this. And we received some really amazing solutions. Now let's go through some other ways to solve the same problem that other people came up with. QGIS has a really powerful expression engine, and you can now do whatever I showed you just using expressions. Salvatore came up with these really creative solutions to solve this whole thing in just 2 steps. He uses the function shortest line, so the same tool I showed you. It is also available as a QGIS function, which you can use in the expression engine. And you use the overlay nearest to find the nearest feature, and then the shortest line to pick that. Let's see how to apply this in QGIS. If you want to look at the full solution, you can access the GitHub link. The expressions I'm using is also available in the presentation. So if you get the presentation here, the expressions are available here. You can just copy paste and try this on the data set. Back in QGIS, we want to run this. So first step, we run this tool called geometry by expression. This is again a very handy tool that allows you to write an expression that uses all the QGIS expression engine and functions, where you can take the input geometry, manipulate it, and generate an output geometry, and it will be used as an output layer. So let's take the buildings layer, and we'll generate a point layer. We'll paste the expression here. So this is the expression. This will go through each building. It'll convert the building lines into individual lines, get a centroid. And a different thing which is again very creative here is, instead of outputting 4 individual point features, you output a single multi-point feature. So all the centroids are still part of the same feature. Let's see how that looks. So now from one step, we went from polygons to centroid on each of the edges. Compared to what I showed you earlier, this, when I select a feature, you can see all the centroid for the same building get selected together because they are the same feature. They are a multi-point geometry. And this is very helpful because now when you say connect this multi-point geometry to the nearest road, you'll automatically get the line between the nearest road point on this road facing surface to the point on the road. You don't have to filter and extract that. So this is really powerful. Once we have this, we can do our run our expression and say I want a line, and we'll take this next line, which is this runs the shortest line function on that. We run this, and now we get the same output that we're looking for. Really fun and very creative solution to go from buildings and road layer to multi-point geometry layer, and then using the shortest line function to connect this. So I was really impressed by this solution. Do check it out and try this yourself. It's really fun to see this in action. Now, as we posted out and invited solutions, the idea was that people would use whatever technology and software that they're familiar with and try this. This is also kind of a fun way for people to take a break from whatever they're doing in their day and try something new, sharpen their spatial analysis skills. So if you go to this slide and click through, you'll find many solutions submitted by people. Here are some of them. PostGIS is quite popular, and it's a great spatial analysis tool. Many people took this data and solved this using a single or multiple SQL queries. And again, you can see everybody got the answer and they submitted their query. So really nice way to say, if you're trying to learn SQL, this is a great way to learn a little bit advanced SQL and say, I know how to do the basic select, but how do I do joins? How do I create new geometries and so on? So do check out the solutions if you want to improve your SQL skills. Folks did using Python, R, and even the QGIS expressions. Again, every toolkit has a slightly different way, but it is achievable in whatever software or platform you're using. Right, so that's the review of one of the challenges. I want to take a pause and see if there are questions, and before we move on to the next part of the presentation.
So far, we have comments from Hans saying nice solutions. I think a question for me on this topic is more the application related. So I'm guessing this could be quite helpful in any transportation networking analysis of some sort, right? Whether, let's say, in an environment of in the industry of delivering packages, and there's more than one doors to an household, or any sort of other analysis or applications you can think of?
Yeah, I think for network analysis, that's one thing is if you want to kind of do network analysis to all these buildings, you need to find a point where you can kind of connect your network to. And this would be a great way to connect your building to the road network. And so you can actually find the route to that particular building. So yeah, similar to what you said, find the nearest edge, the shortest path from a road to a building, and that would this allow you to create this for your data set.
Okay, we have a comment from Daniel. It says other variants since 3.24 processing algorithm, shortest line between features. So that's just one step, but will not be in the centroid of the edge.
I think there are both the options. If you look at the shortest line between features, you have options that you can connect to the centroid of the line or to the nearest point on the feature. So I think you can select both the options, whichever you want. This one is harder. The centroid is easier. You can do it in other ways, but finding the nearest point on feature, even when there's no centroid, no vertex, is much harder. So I think this one is more useful. But again, I think there is an option to do the centroid as well here.
All right. Thank you. Do we have any more questions before going to the next session?
I just have one. Why did you use the centroid of the like edge facing the road, or not, rather than the actual shortest point? Is there any particular reason there, or just because it goes in the middle of the line? I'm just looking at some of the buildings.
Yeah,
you can,
you can actually do. Yeah, it's a good question. So I think we can just take the building and say connect it to the nearest on the road. So if I do this, you'll get something similar, but you will see the the solution looks like this, right? It finds the nearest point from the building and says, this is the nearest point of the building on the road. And it might be okay for some application, but ideally you don't want a corner to be connected to the road. You want a road-facing edge to be connected to the road. So I think the way the problem was framed from one of the participants, like they want to connect the road-facing edge of the building to the road. So I think that centroid was a little more nicer solution to this, but otherwise you could have just gone directly to using the shortest line and connect it like this.
Yeah, I'm sorry, I just wondered why you used the centroid particularly. You didn't just use another point on the same edge. Like I understood you wanted to use the edge, not the corner, but I just wondered why you went with the centroid, not an arbitrary point that's not on a corner or a vertex.
Yeah, you could probably use, if there is a better point, better representation of the edge, you could do this. The centroid would be, I would think is more representative of what the edge center is. So that's what I use. But I think if there is a better idea, I'm sure there might be a better solution to that as well.
Okay, thank you.
Right, I think we can go to the next one. This one, I named it as a variable buffer. The idea for this challenge was that we all have done buffers in a GIS environment where we take a point layer and extend it out in space towards a certain distance. We can do a buffer of static distance, or we can kind of compute the distance dynamically based on a field. But here is a kind of variation of this where we wanted to do a buffer of a layer so that it encompasses n number of features from another layer. So here, the challenge was we have two layers, layer A and layer B. We want to buffer features in layer A so that there are exactly 5 points within each of those buffers. Again, this idea would be if you want to determine accessibility or service area, and say, I want to know at what is the kind of service area or buffer zone where I have at least 5 different features for a certain amenity. So again, the smaller the circle, the more accessible that particular place is, the larger circles you have to travel further on that. So if you want to do something like this, this is not very straightforward, but we'll see how to do this in QGIS. Again, we had many different approaches and submissions. So let's go through and learn different approaches to solving this. Out of all the submissions that came across, I was very impressed by this one. Abhimanyu took this problem and solved it with a single, very short expression. And the idea for this expression was using this overlay nearest function. So for each point in layer A, the overlay nearest is an aggregate function, which can read features from another layers. And you say, for each point in my input A layer, read features from input B layer, and give me the 6 nearest features. So I get all the 6 nearest features and then compute the distance to the 6th point. And that in a buffer using that, I will be having 5 points within my buffer. So this is kind of a clever way to dynamically compute the distance to the 6th neighbor and use that for buffering. So we'll use this and see how that works. Let me just switch back to QGIS. And this is our input data. So the green one is layer A. We want to buffer it so that we have exactly 5 points from the blue layer within each of the buffers. So I'm going to do buffer. And instead of specifying a static distance, we are able to do the data-defined override and write an expression. So here is where we will take this, and I'm going to use the expression here. Let me just explain the expression a little bit. So we use this expression called, the function called overlay nearest, which will take another layer. So we are running this function on layer A. We say overlay nearest, the features from layer B, get me the geometries of the 6 features. So we just say, give me 6 features, and what you get is a list of all the 6 points that are the closest. And they are sorted in the order of the distance. So we can just say, give me the 6th one, which is index 5. So index starts from 0, it's the first feature. So 5 is the last one. You can also do -1, which will be the last. So give me the last feature. So now we have the point, which is at the 6th neighborhood distance. And we can use the distance function and say, give me the distance from the geometry, which is the current point in layer A, to this feature that we found, which is the sixth neighbor of this point in layer B. And we use this. This will be dynamically computed for each feature in layer A, and we'll get the buffer. So when we run this, you can see now I got this buffers, and since we buffered to the sixth point, we get at least 5 points inside of this particular buffer. One of the things you'll notice is that buffers are not actually circles. They are polygons made out of the small edges. So there is a possibility that even if you buffered it to the edge of this distance to the sixth neighbor, the buffer actually doesn't encompass that, and you might miss that. So one way to kind of ensure that this works is you also might want to increase the number of segments. So if I increase the segments, that is for 1/4 of a circle, you use 20 segments to create the circle. And this will ensure the shape of our buffer is actually more circular, and will have a more chance of
Hi, can you hear us? I think
Yes.
lost you. Okay,
Yeah.
great.
What was the last thing that you heard?
Hold on, it's glitching again. I actually don't recall. Jeremy, sorry, I was just checking the chats. You have another question. I'll let you know now. But we just lost you like 5 seconds in.
Okay. So this whole, did you see the whole thing? Or?
Yes. So after you showed the buffer, and that the buffer includes the sixth point, so all the other 5 points are within. Yes, okay. From there, you're struggling. Yeah.
All right. So we saw this buffer, but one of the problems with the buffer is that the buffers are actually not perfect circles because they are made out of different edges. So one of the things you can do is when you're doing the buffer, you can increase the segment parameter, which will have used more line segments to approximate the circle. So instead of 5 segments, we can increment it to say 20, and we'll get a more circular shape of the buffer. Even within that, you can see that because of the precision issues and the number of segments required to approximate a circle, we still might or might not miss the sixth neighbor. So this is a little bit of iffy. This solution works for kind of, it's a good general solution, but it's not perfect. And we probably want to have a more robust solution. So we had a really nice idea submitted by Michael, who submitted a PostGIS solution. It says, instead of just buffering to the 5th neighbor or 6th neighbor, and depending on the shape of our buffer, whether the 5th or 6th might be included or missed out, we can actually do something clever and find the 5th and 6th neighbor distance and compute the average value and buffer to that. This will ensure that we have exactly 5 neighbors and we don't miss the 5th neighbor. So this is an interesting approach. We can, of course, apply this to QGIS as well, and we'll improve our previous solution and say now we'll compute the distance between the 5th and the 6th neighbor, and then take an average of that and compute the buffer distance to that. So I'm going to show you that expression. So back in QGIS, now we use the buffer, and now we'll take the layer A and improve our expression where we do both the 6th neighbor and the 5th neighbor and compute the distance which is between those. And if we buffer this, you'll see that now our buffer is between the 5th and 6th neighbor, and it ensures that each buffer has exactly 5 points. So this was a little clever improvement on the main solution, and it also works quite well for this. There were, again, many other solutions. There were quite a few people who use QGIS expressions. You can also do this using the processing tools. There are a set of tools to compute the nearest neighbor. You can find the sixth neighbor, filter the attribute table, and then use the attribute for the sixth neighbor to do the buffer, and similar thing what we did. So again, you can definitely use the built-in processing tools to be able to achieve that. Again, folks did this using Python and R. Similar concepts, but again, requires a little bit more code for iteration, etc. Not as elegant as QGIS, where you can just have one expression that can just do this in a single step. We had, again, what I love about the spatial community is that everybody uses their favorite tool and they have their own workflows. So people apply different technology that they're familiar with. They would use Google Earth Engine, Lucia and Lindsay use FME, and were able to do this. Similar concepts, but application and the exact steps are different. But I was, very happy to see people using whatever tool they're familiar with and coming up with a solution to solve this one. Right, we're done with this one. We can pause and see if there are questions.
Okay, so the first question was actually related to the previous one. There was a bit of a delay. So the question is how to perform connect specific points on a target feature. So the use case they provided is how to connect property to the nearest manhole.
I think the same approach would work, where you take the input layer of all the polygons and the point layer, manhole layer, and the shortest line algorithm should be able to just go and connect the line to that. So I think that should be very straightforward. And again, as we had a bit of discussion, what point from the nearest edge do you want to connect to? I use centroid, but if you want any other point, you need to first extract that point and then use that to connect to the nearest manhole.
So if they were to use the method that the model that you created, the only difference would be instead of road, you can now have the point data, but the other methods still stay, right?
Yes.
Okay, perfect. All right, I hope that answers your question. The second one is relating to the second section. It says, can you please explain the concept of the segments?
Yeah. So let's... let's do a regular buffer. So I want to buffer it by, let's say, 100 meters. I'll take default parameters, and we have this buffer that we created 100 meters around each point of layer A. So this is the point, and we buffered it. Notice that the parameter uses, we use 5 segments. That means to create a circle, QGIS will use 5 segments in each quarter of the circle. So if you take this and say from 0 degree to 90 degree here, there are 1, 2, 3, 4, and 5 segments. And that approximates 1/4 of a circle. GIS typically, QGIS has support for curves, but most other kind of spatial systems still rely on lines to approximate a circle. So we say we have this 5 segments approximating 1/4 of a circle. We can increase the number of segments and get a more and more closer representation of the circle. So if I increase it to say 20 or say 25, it'll use more segments per feature, and it'll have a much closer shape of the circle. So you can see now this one has, it looks like a circle, but if you zoom in more and more, you'll see that there are still lines. There are 25 lines in each segment. So something to be aware of. One of the times I had an issue where I was doing some analysis in Python, and my colleague was doing this in QGIS, and our answers didn't match, our statistics didn't match exactly, because both systems had different defaults for how many segments they used to approximate. So once we matched it up, our analysis was exact. So again, be aware that all systems will use number of segments to approximate a circle. Make sure you know what the defaults are, so you can choose the one that is appropriate for your analysis. We'll move on to the next one. This one is a more recent one, kind of an interesting challenge, again, very real-world applications of this. The idea was that we have some polygons. These polygons were detected from satellite imagery. So we just say these are a group of pixels which are continuous, and we extracted those. Those are the urban area polygons. But we don't really know what the name of the urban area is, because again, the satellite imagery didn't have information. If you want to add the name of that particular polygon, we can take another layer. So there are data sets which says the point features are representing different cities. So for this example of a data set which has got different populated places, each place is represented by a point along with the population. Many of these polygons, you can see this is the polygon for the city of Mumbai. It's a fairly large urban area, and there are kind of two populated places within that. Now, if you want to say what is the name of this polygon, you would want to name it after the city that it's contained, but it's having the highest population. So you can see there's one place point named Mumbai, another one called Kalyan, but Mumbai has much higher population. So I want to assign the name to this polygon based on the point having the highest population. And this becomes a little tricky if you want to just join two layers. You can just do a spatial join. But how do you kind of restrict your join to say, I want to join, but only with the feature having the highest population? And that becomes a little tricky. So we wanted to see how people approach this problem to do this conditional join. Again, as with all the challenges, people came up with really creative, really interesting solutions. So I want to go through some of them and see how we can solve this. First one I want to show is using this thing called geometry generators. This is using QGIS expressions to dynamically create new geometries from a feature and assign a label to it. So Toto Fianca, he's an expression guru. If you want to learn about QGIS expression, do follow him on Twitter. He came up with this really clever expression that does this in a single expression. So it does the join where it says for each polygon, find me all the different points that are contained within it. From that, pick the one having the highest population and display a label for that. So let's see how to do this. We'll show you what the aggregate expressions look like. So here we will say we have this multiple points. I want to just turn off this point layer. We're going to say we'll take this urban areas layer, and we want to now label this polygon with the point having the highest population within that. So we'll just write an expression on this layer, which uses data from another layer and figure out what is the label. So I will go to the labeling, and we write an expression. So this is the expression. Again, it uses the overlay contains expression, which looks at another layer, finds all the features which are intersecting. When you have this really long expression that you want to keep repeating, this QGIS offers you with this another function called width variable. That means you can say width variable max, use this long expression. So the whole expression can be referred using this keyword max. So whatever word you choose. That means I don't have to rewrite this expression again and again within my expression. I can just say, when I say at max, that refers to this expression. And let's see what happens. When I run this, you can see suddenly I have a label on my polygon. And this label comes from another layer having and finds the point having the highest population. And it also displays the name as well as the population. And you can just do this dynamically. So really cool. Again, the features that don't have any points within it, they are not labeled. So again, this is one single expression to solve this. We can also add the point location. You can see the point is somewhere here. We don't have the point geometry. But instead of creating the geometry, you can use the geometry generators in QGIS. So I am in the symbology here. We have one simple fill applied to all the polygons. QGIS allows you to apply multiple styles to each feature. So I can just say plus, and now I can say I have a different style. I can style it differently. But instead of doing a simple fill, I can choose the geometry generator as the symbol type. Geometry generators allow you to write an expression that takes the features geometry, manipulate it, and generate an output geometry, which will be used to render that particular layer. So we can now, instead of creating another layer with the points and doing this, we can just write an expression to do this. We'll say this one should be a point, and we'll say write the geometry generator expression. So I have the expression here. Let me just see where is it. I missed that expression. Okay, let's see if this one is the correct one. Yeah, so this is the same expression from here. So again, I took this expression, and now we have a point. So this point has been rendered dynamically. You can see my point here is off. I just added a new symbology, which finds the location of the point from the other layer and just renders them in this red color. We can keep going, and we can say, I want to now place the label not just anywhere, but I want to place it at the wherever the geometry is. I can just add it here, and you can see it's placed next to the point. So again, with the expression, you can control a lot of things and dynamically create this. This approach is super helpful where you say, I just want to create a map. I want to create a rendering of this data. I don't want to duplicate layers, create multiple symbology. You can just use a single layer, write an expression, and dynamically generate these labels and create your map. One place where kind of QGIS expression are not very efficient is that you can see as I zoom out, it takes quite a while to evaluate this expression, because one limitation of the QGIS expressions are that they don't use spatial index, the aggregate expressions, all the overlay intersect, overlay contains, they don't use spatial index, and therefore they can be very slow. This one is a fairly large layer. If I look at 11,000 features and many thousand points, so again, it has to check against each geometry. So that's why it can be slow. So if you want to do this for analysis, we will look at another approach, which is much more efficient than this one. So when I was trying to solve this, again, we had to figure out how to do this efficiently. It's a fairly large data set, and we want to use the spatial index. So I ended up writing a custom PyQGIS script. So similar to how we have a tool in the processing toolbox QGIS that does spatial join, I wrote a tool called Conditional Spatial Join, which is a Python script that goes into a processing toolbox and allows you to run this tool with specifying the condition. Again, since PyQGIS can use spatial index, this algorithm is highly efficient. And once you have the spatial index, it goes very, very fast. So it finds all the intersecting points within a polygon. Depending on the chosen criteria, it filters to the point having whichever is the criteria and transfers the attribute of that particular feature into the polygon. So let's see how to do this. Just going to load this project again. Okay. So you have the custom script. You can copy paste the script here. I have the script here called Conditional Spatial Join. This is what the script looks like. This uses PyQGIS API to create a new tool, which has certain inputs. And the core of the algorithm is where we, for each polygon, we find all the features within the bounding box of that. And this call actually uses the spatial index if this is present in the layer. And that is super efficient to find all the features instead of iterating through each point in the destination layer. And then we just use the condition to find the feature and set the new attribute value. This script becomes another tool in your toolbox. If I open it up, you can see it just looks like on the processing tool. Let's select the input layer. Let's say we have the urban area layers, we have this point layer. What do you want to join? So we want to join the name. My condition, you can select highest to lowest, and say my conditional attribute is population. So we can join the name of the attribute from this layer having the highest population. Let's run this. If I run this, you can see there's a message here that no spatial index exists for input layer. And you can see my processing is quite slow. It's making this slow progress. One tip is whenever you see this message in QGIS, that's a time to stop and go and add the spatial index to your layer. Adding spatial index is very simple. There's a tool in the toolbox called spatial index. Open it up, run it on each layer that you're using for your analysis. And creating a spatial index is very fast. It doesn't take much time. but you'll see how it helps, where let's go and run the tool again. I can go to history and rerun the tool. So this was the tool that I ran. I had configured it exactly the way I did earlier, but now you can see it run. You can see it makes much faster progress. Instead of taking maybe 3 or 4 minutes, it finished in 3 seconds. We were able to process fairly large size layers and do this join between those 2 layers in just under 5 seconds. Open the attribute table, and now you can see for each feature here, we have the name of the feature containing the highest population. And again, the way I've written the script is more generic. It can, you can use it for your specific problem, and you can pick the attribute that you want. So PyQGIS allows you to kind of customize and build tools for your needs. Always use the spatial index when you are writing or using the tools in QGIS. That'll give you a huge performance boost and can do your analysis much faster. So this was the PyQGIS solution. We received one more solution, and I want to show this to end the last session, is PostGIS. Now, PostGIS is not QGIS, but I consider it a close cousin of QGIS. QGIS was built as a PostGIS viewer, it's kind of integrated, and if you want to level up your analysis, using PostGIS as a backend for your analysis will give you really huge performance benefits. So if you never use PostGIS, you can install it locally. You can just use it for yourself, load the data, and run some queries. Use QGIS as a viewer, as a front end for that. That'll give you, allow you to do not many complex things with just little code. Paul Ramsey, the co-founder of PostGIS project, also chimed in, and in the challenge he replied that you can just do this very easily in PostGIS, even compared to other SQL, because PostGIS has this really nice feature that allows you to, it's called distinct on, which can allow you to select the feature having certain criteria from a duplicate. If you don't have this, you have to write a much more complex SQL query using a window function or some other lateral join or something like that. So let's see this in action. I want to show you that how you can use PostGIS to do the same analysis through QGIS and run this query and see this. So let's take this. We're going to copy this query from here. So let me just remove this one. I have a PostGIS running, so I just downloaded the PostGIS installer, ran it, and initialized it. I'm not using it to share data or publish anything, so I don't have to worry too much about security, etc. I'm just using it as a backend for my QGIS. So it's just the default setup that is installed. Now you have this available through your Postgres connector here. You can see I have just one database that I've configured, which is running here, and it's currently empty. There's no data set. I want to analyze this to data set. You can simply take this layer and drop it to your database here, and it'll just import it. So just go and import this here and just create those 2 data layers with the spatial index within my PostGIS database. So I've imported both this data set, and now I can run the queries. Multiple ways to do this in QGIS. That is DB Manager, which allows you to kind of interactively do the queries. If you are using PostGIS in your processing model, you have tools in the toolbox, which allows you to run Postgres data. So there is this tool called Postgres Execute SQL. We'll select the database that we want to connect, and now we'll do the query, which Paul Ramsey suggested. But instead of just showing the result dynamically, we just create a new layer from this in the database. So this is the query. It says create a new table called urban joined, and run this query to find the nearest feature from there. Let's run this. Again, it finished pretty fast, around 6 seconds or so. So we could do this as quickly as we could do with a custom PyQGIS script. Refresh, and you can see there's a new table here. Let me bring in this data. And now we have this new data layer where you have the name of the polygon assigned to each polygon along with the population of that. So again, really simple and clever PostGIS solution. If you not use PostGIS and want to learn SQL, this will be the easiest way. Just install PostGIS locally, connect QGIS to it, and start running queries from there. want to show some other solutions that were submitted. Quite a few PostGIS ones. This one's using different set of queries. Again, it works. I don't know how, what's the performance of those, but I would suggest the select on one would be the fastest among those. We had folks submitting solutions using QGIS as well as GeoPandas as well. All right, that's the end of our bonus challenge. We are coming close to the end of the presentation, but I want to take any questions on this one.
So we have two questions. It's which version of QGIS are you currently using? And
I'm
the
using
second
the,
one is, sorry, yeah?
I'm using the QGIS LTR 3.28.
3.28. Okay. And the other question is which version of QGIS is very good at processing various tools for Windows?
For Windows. So
Yeah.
in general, the thumb rule is always use the LTR version for QGIS. That is the most stable, most bug-free version of QGIS. So if you're using for your work, you can use LTR, which is the current LTR is 3.28, and that should give you the most stable as well as the fastest approach. There might be certain tools that are available in the latest version, which you may want to use. So you can run them side by side. I typically run at least two versions of QGIS on all my machines. I have the latest version, currently 3.30, and the LTR 3.28, and they coexist side by side without any problem. Use the official installer, and they'll just go in at different places, and you can use both. But for routine work, for production work, I always recommend using the LTR version.
Okay, perfect. I see we have a question from Toto as to where you can find the slides. That is in the description, but I'll type it out now in the chat as well. And then we have a question from Dennis saying, I have a spatial analysis challenge of my own for which I have no solution yet. Where's the best place to post it? Where can I forward it directly? Or maybe can I forward it directly to you, Mr. Gandhi? Thank you very much.
We have the whole QGIS community watching, and in there, I would suggest, I'm happy to answer the question. Take a look at your email. My email is on the last slide. I'll show this to you. So you can email. I try to answer and help as many people as I can. But do use other forums. So Stack Exchange, GIS.Stack Exchange is a great forum. A lot of experts out there. Try to post your question there, and people will solve this. Also, it's also discoverable, so people can find the solution later. Use Twitter. I'm still on Twitter because there are many amazing geo people I still like to follow and learn from. So do post on Twitter, and tag. You can tag me, and I'll try to spread word around and see if you can find a solution to that.
Perfect. This might be a silly question because the chances of this happening is almost very rare. In the example that you showed us now with the polygons being named by the highest population, let's say there was actually a place that had the same amount. So, like I said, it's quite rare. But if they were to have the same number, how would that have handled that query?
I think the way it works, I think the default, the features are sorted by the feature ID. So whenever, I think whichever feature was created first in that case would be selected.
So it overrides. Okay.
And so I think if you have kind of same one, this one, the Postgres one will just select the first one. If you read the documentation of the distinct on, which is say the first one that's available, the first one would be the one having the lowest feature ID. So one that was inserted in the table first.
Okay, thanks. And then, sorry, lost a question. Oh, well, we got a question now. I love this challenge. I'd like to know if we have a group for Earth Engine as well.
You can definitely participate in these challenges and submit Earth Engine solution. I think we have had a couple of people who have solved this in Earth Engine. I'm also a heavy Earth Engine user. So I would say just take a look at the problems and see if you can solve this in Earth Engine. Earth Engine is a little harder because there are fewer built-in vector analysis functions, but it's still possible to do a lot of these things in Earth Engine. So I would say just use that. I don't think there's a specific group that is on Earth Engine, and I would probably don't want to kind of restrict it to Earth Engine. I think we can all learn from each other. Sometimes I see a solution that somebody did using R, and so that's really clever. Maybe I can adopt it to Python. I'm a Python user, so I think it's good to kind of have it all in one place, and everybody can learn from each other.
Great, thank you. That's all the questions so far.
Great. So since we have all the folks, I've got your attention, and maybe you're inspired to now give QGIS a try. Maybe you want to learn some expressions and try something out. So I have a challenge from you. This one is an interesting one. Herman kind of asked this on Twitter, and he has a real world use case for it. I just took some public domain OSM data and created a sample data set to replicate this. The idea is we want to do a nearest neighbor analysis. Here we have the pink points, which are the schools in a region. The red stars are the colleges or another type of school. We want to connect each school to the nearest college point. So connect the pink point to the nearest star point, but you want to have a constraint that the nearest neighbor has to be in the same admin region. And this is often the case where you want to avail certain facility, but you are restricted by where you are, and you want to go within the same admin region. So as a figure here shows that you want to connect the pink dots to the nearest red star, but you should not cross any admin boundaries. So if you do the regular nearest neighbor, you'll get an answer like this, but you need to figure out a workflow to say, I will connect each dot to the nearest star, being in the same admin boundary. So this is an interesting problem. I would love to see how people can solve this. If you want to get this, you know how to get the slides, get the sample data here. I'm going to be posting this on Twitter and shortly after this talk. And once you solve it, just reply on the thread, and with your solution, we'll kind of go through all the solutions in a week, and then we'll, I'll post out the solution. So again, go through all the other solutions as well once you've figured out your own, so you can learn from each other. And I'll keep doing this. So again, if you have kind of interesting challenges that you like to get answers to, or kind of are a good fit for this, let me know. I'm happy to kind of post this as a series and for the benefit of everybody. That's it. I want to end the session just by leaving you with some thoughts. The reason for doing this session was to show you that QGIS is a really versatile tool. It can do a lot of things. The built-in toolbox has great features. You can use the modeler to create your workflows. PyQGIS is really powerful when you want to add some customizations. You can use PyQGIS to build new tools with little effort that can integrate with the rest of the things and learn expressions. You can see a lot of the advanced solutions use expressions. And once you learn the QGIS expression, especially the aggregate expression, it opens up a whole new world to you, and you'll be able to do stuff with very little effort that otherwise would require custom coding, or maybe not being able to solve the problem at all. And lastly, again, explore PostGIS. That would really help you scale your analysis and do things without really. PostGIS actually scales to much larger data sets. So if you have very large data sets, PostGIS would be able to handle them much better than the native QGIS solution. That's it. Thank you all. It was great presenting here. If there are other questions, Q&A, I'm happy to answer them now.
Thank you so much. I see there's a comment. I'm not sure. It says use aggregate brackets. So I'm not sure if that's referring to the previous method. Oh, yes, for the solution, I suppose. Yes, okay. So we already have one solution from G Club Media.
Okay,
so
nice.
Do we have any more questions before we end the live stream? Just wanted to double check. While that's happening, thank you so much, Ujaval. That was absolutely amazing. We've learned so much. Thank you so much. Very interesting. And the QGIS community and everyone live stream is also sharing their gratitude. Lots of thank you messages, and that this was very interesting. So thank you so much for joining us on this day.
Yeah, thank you for moderating and hosting, and always great to be here. Do reach out to me, and my email is on the presentation. Happy to answer any questions or help you get started with QGIS. Thank you.
Please, thank you so much. That's perfect. Yeah, I don't think there are any more questions. I think the biggest thing that I actually am quite impressed by, especially by this challenge, is one, how people always contribute to open source and always willing to help and try the challenges. And secondly, I think I'm quite grateful that there were all different methods. So if you don't like to code, it's there. If you like Postgres, it's there. So that was quite amazing. Thank you so much for sharing. All right, I think there are no more questions. I think that will be all. Thank you so much to the community as well for joining. I hope you enjoyed it. Later on, we're going to have another presentation around 3, focusing on the SOAR plugin, and we hope to see you there as well. Thank you so much.
Thank you. Bye-bye.
Bye.